Welcome to my channel, TechneMoira, for a new episode. And today, on the bench, we have a Saba Sandy portable radio from the late 60s to repair and restore. So, grab a snack or a drink, sit back, and enjoy the show. So I recently bought this little portable radio on eBay, to be precise, and it does have its issues. Well, first of all, the antenna is obviously broken. The tip is missing, and somebody did a sort of a quick quote-unquote repair to it. It also has a carrying handle, which is this here, and as you can tell, the carrying handle has a slight bend to it, so that will need some looking after. It's also the chrome is oxidized and dirty, so that will need a bit of cleaning as well. Also, the carrying handle normally is attached to a screw, to two screws, one on the right and obviously one on the left side. I have, fortunately, the original screw, but for some reason or other it doesn't want to stay attached inside. So we'll have to look into that. It does come complete though. It has all the original knobs, and the cover, the dial cover, which is this translucent piece of plastic, is unbroken. So no cracks and no scratches to mention, or well, maybe a few scratches at the top right here, but nothing that I can't fix or clean. So yeah, it has its usual dents and scratches and everything. It's pretty dirty actually. And then the other thing to mention is that this radio has an AC power supply inside, but the connector for the power supply, which normally sticks out here in this opening, and when I look inside the radio, I can see it floating about somewhere. I don't know if you guys can see this, but so the AC connector is down there, yeah, inside the opening. But it's yeah, there's obviously something wrong with it, so I need to repair that as well. Plus, of course, the radio is pretty old. It's from the 60s, so I don't doubt that there are quite a few parts to be checked and to be replaced. So most of the repairs, quote unquote, I will need to do to it are cosmetic, I'd say. Also, the thing that made me decide to buy the radio is because it is complete. It comes with the battery cover actually. So the battery cover is located at the bottom of the radio, and usually, you know, when you buy portable radios, this often is missing, but lucky me, it came with the battery cover. I undid the top three buttons, one on the left, which is for the volume and on off, one for the tone, and one for the tuning. So, and you just undo those buttons by pulling them off. So I did that first. Then I unmounted the glass cover of the dial, and the cover is held on by only 2 screws at the top. So, and there you go. So this is the glass cover, you could say, or the plastic cover. And what I did then next is I unscrewed the screw for the one screw which was left for the carrying handle, and then there are 2 fat screws on either side. Well, there's 1 fat screw on either side, so 2 of them, which you also need to unscrew. Those are Phillips head screws. And once you've done that, you open the radio up simply by pulling up the whole case like this. Okay, like this. Alright, so to be able to work on the internals of the radio, I decided on the one hand to release the speaker from its enclosure, which only takes 4 screws as such, but I will also unsolder the speaker, because I just don't want to damage it, not even by accident, because reconing a speaker is is just like restringing a radio, is really not a fun job. Yeah, so I'm going to unsolder the wires to the speaker. Okay, there's a black and a green wire, and the green wire is obviously the positive, and the positive on the speaker is indicated with a little red dot here. Okay, so the green wire goes to the positive, the black wire goes to the negative. Why they chose a green wire instead of a red one beats me, but I mean, that's how it is. Yeah. The speaker has 4 little rubber mounts here, obviously to reduce the amount of vibration that goes into the radio. And I'm going to set aside the speaker so to make sure that I can never damage it, right? So there you go. So as you can tell, with the speaker out of the way now, I can reach practically every part of the every inner part of the radio. So hopefully there will be no need for me to unmount the main PCB of the radio, which would be really annoying, because the dial capacitor, which is located inside the little box here, is well, connected to the whole dial mechanism, which is this complicated string setup here, and I really don't want to mess with it if I can avoid it. So yeah, the next thing that you'll notice is that I lifted carefully and gently the top cover, which is actually the dial, yeah, the tuning dial, yeah, and the tuning dial is silvery in color, but it's not metallic. It's actually plastic with some silver paint on it, on top of it, So again, when you clean this, be gentle with it, and don't use anything corrosive, or you may damage the painted dial markings, right? I don't know if it's paint or ink, but I wouldn't take any risks if I were you. And if you are going to clean the dial, use very mildly warm and water with a tiny little bit of dishwashing soap, okay? But don't use anything more aggressive than that, or you might simply damage your dial markings. Yeah. So there you go. If possible, if you can clean it with just water and a rag and gentle rubbing, that would probably be better. But don't use anything corrosive like alcohol or, God forbid, acetone or stuff like that. No. Just use soapy water. Alright, I replaced 5 electrolytics in the radio. Here they are. And all of them measure rather bad, but one was completely bad, and it's this one here. I had to remove it because, as you can tell by the corrosion around its lead, it was chemically leaky, so it was absolutely bad. So I'm glad I replaced them all, and of course I also took the occasion to clean the radio out, because there was a lot of dust and grime inside of the radio, and now at least it's clean and a lot easier to work on. I also removed the cap to the tuning mechanism. It has been damaged slightly. I will repair the damage as well as I can, but the damage wasn't caused by me. It must have been done in the past by someone who wanted to have access to the dialing mechanism. Yeah, and you can actually see the dial capacitor over there, and it's a very nice little capacitor actually. I rarely saw one like this. It looks to be completely copper. Yeah. It might be copper covered steel though, I'm not sure. But yeah, it's a really nice little tuning capacitor, and it has a nice plastic cap on top to prevent any debris or dust to enter it. So that's nice. I cleaned it out and I greased it. You see the gear mechanism there. Okay. So I used some silicone grease to grease it, and before that I cleaned it as well as I could with some WD-40. Obviously the cleaning wasn't perfect, but let's say most of the dirt and rust was removed. Yes, there was some rust, as you can tell over there. Okay, so let's see. There. So there's still a few traces of rust here and there, but most of the rust was removed. And like I said, I used some silicone grease to grease the mechanism, and now it runs smoothly again. Okay, so So far so good. All the capacitors have been replaced. So what I need to do next is to repair a few minor damages to the radio with some glue. I'm thinking either thiocyanate or super glue repairs or some epoxy. I'll have to see once I get a closer view. Before I move on, there's one interesting detail that I want to show you inside this radio. This connector here suspiciously looks like a vacuum tube socket, right? But apparently it's not. It's more like an access point to do some measurements on the radio, yeah, or some IF alignment. And apparently the Saba engineers decided to use a vacuum tube like socket to make all the measurements and test points available to a future tech. The original filter capacitor for the power supply, which is this one here, was a 2500 microfarad 10 volts, 15 volts capacitor. Okay. Now, I looked all over my stash of components, and I just couldn't find a 2500 microfarad 15 volts electrolytic. So I did the next best thing, and I used a 2200 microfarad rated for, I think, 35 volts. Let's see. Or is it 25 volts? 35 volts, yeah, like there. So I use the 2200 microfarad 35 volts capacitor instead. It shouldn't cause any trouble, and if push comes to shove, then I might still add another capacitor, say a 330 microfarad in parallel with this one, if it really is making any difference, which I don't think it will. One of the things that need repair is the antenna, and more specifically the tip of the antenna right here. So somebody in the past must have thought to repair the broken tip of the antenna with a quick fix by curving it into a hook like appendage. And I don't like this, obviously I don't, and therefore I looked around in the parts that I had, and I found this very nice button shaped aluminum part here. And what I intend to do is to drill a hole which is just large enough to press the antenna into it. So I want to use a press fit with this little aluminum button like cap, let's say, yeah, and to make it fit on the antenna I will cut off the part which is, well, basically useless now, that hook shape, and file it to a nice smooth end, and drill a little hole inside the aluminum button here with a very fine little drill. So that's one of the things that I want to do now. Also, you remembered when I moved the radio around, there were some rattling noises inside, and it turns out that the screws which originally held the power connector, the AC power connector of the radio, were rattling around inside the radio. Yeah. So I cleaned the power connector, which is some sort of translucent plastic, and it turns out that the holes to which the screws were originally fitted, yeah, are broken. Actually, the sides of them are broken. So what I'm going to do is I'm going to clean the area around the screw holes with some alcohol, and then scuff it up a little bit with some sandpaper, and then use either some cyanoacrylate, I never can pronounce the word, super glue, to repair those holes. And if that doesn't hold, then I'll use some epoxy. Alright, I cut the hook-shaped ending of the antenna, as you can tell. Don't know if you guys can see this, but right there, okay. I cut the tip of the antenna and filed it to a workable tip, let's say, and then I drilled a little hole inside the aluminum puck I found, remember? So there. Okay, not completely through the puck, but almost. And what I'm going to do next is I'm going to glue the puck to the end of the antenna like this. Okay, obviously a bit straighter than this, but like that. Okay, and that will be it. That will be the repair of the antenna. Now, a small tip to any of you who want to repair the same kind of stuff, buy yourself one of these. These are glass fiber wipers. They allow you to clean a metal or plastic surface really thoroughly, and it's basically like very slim, very small glass fiber strands packed together, and they scratch the surface you want to use. You want to either weld to or solder to or even glue to. So this is really, really useful, but there's one warning. This is glass fiber stuff, okay? So if you're going to use this, you better use this in a well ventilated area, and preferably wearing a dust mask. Alright, the head of the antenna is repaired. Well, I should say is glued. So now I'm letting the glue cure, and it's the same here for the AC connector. So I glued it all back together, and now the glue needs to cure, right? So granted, it's not very pretty, but like I said, the connector is hidden anyway within the cabinet of the radio, so it just needs to be solid and reliable, not necessarily pretty. Alright, I managed to repair the antenna and yeah, as I said a few moments ago, I retooled the little aluminum puck which I found in my stash to function as a head for the antenna, and as you can tell, it looks okay. And I glued it to the antenna tip here with cyanoacrylate. Yeah, I finally managed to pronounce it correctly. With cyanoacrylate I fixed the right type of nut at the attachment point of the carrying handle, right down there, and I did the same thing on the other side. So that the plastic which covers the dial of the radio is scratched in a few places and is a little bit dull, so I think you can tell when you see the reflection of the lamp above me in the plastic that the lens or the glass cover, so to speak, of the dial is not too clean anymore, not so very translucent any longer. But I do have this, which is a buffing compound which I bought on a Polish page on eBay, and it's called Lamp Doctor Headlights Renovation Paste. Okay, so it's a polishing compound which allows you to polish the lens of a car's headlights, right? But I tried it before on a plastic like this for another radio, and it worked out just fine. So what I'm going to do is I'm going to buff the lens over its whole length with this compound, and hopefully it will come out a little bit better than it is right now. Obviously the deepest scratches like the one here, I don't think I can buff that out completely, but yeah, I can try to mitigate it a little bit. Alright, I'm done buffing, and okay, it's not a gigantic improvement, but it's certainly better than what it was, right? So yeah, you can still notice a few scratches, and I could basically buff this for another hour or so, and it would probably come out even better than it is. But yeah, I mean, I don't want to spend hours and hours buffing a piece of plastic. Besides, frankly, you know, buffing or polishing plastic like this, yeah, basically means taking off a layer of the plastic, right? So with something very similar to sandpaper, but a lot finer grain than sandpaper, right? So yeah, I mean, for example, these scratches here, right here, I could take them out if I sanded the whole plastic lens with some very fine grained sandpaper like 2000 or 2500 grit for a while, you know, wet sanding it, and then eventually I would get these kind of scratches out of the plastic. But that's something that takes really hours of work, you know. Just ask somebody like Bob Anderson from the B. Anderson TV channel. He did the same thing for lenses or covers, yeah, of TV sets. Not a little lens like this. I mean, okay, you see how large it is compared to my hands. He did it to entire covers for a whole screen of a TV set. Okay, so you can imagine the amount of work that goes into polishing this kind of plastic. Alright, I'm going to mount back the antenna, and unfortunately the only way you can do that is by placing it right into its socket, like there. There's a slight protrusion down there, let me show you. Alright, so down there, this right there, is a protrusion in the plastic over which the base of the antenna fits. So you place it in like this, okay. And once the antenna is on its base, right there, you can swivel it 180 degrees inwards, like this. And there you go, there. Now it's in its location. And now you need to solder this isolation capacitor here to the antenna. Now unfortunately for me, the antenna is one big piece of chromed metal, yeah, and it conducts heat fantastically well. So to make the solder melt on the antenna, I need a big fat soldering iron like this. Okay, this is a 150 watt soldering iron, and that gives enough heat to, there you go, to melt the solder. And now I should be able to solder the capacitor back into its rightful place without burning my finger, that is. Come on. Wow, this is getting hot. There you go. Okie dokie. So that's very unfortunate, but it's the only way I found to be able to quickly solder the capacitor to the antenna. Alright, I connected the Saba up to my Wavetek over there, and through the isolation transformer. Okay, because I'm not quite sure yet if it'll work properly on full AC power or not. So I connected it up here, yeah, with some extension wires to its AC, its built-in AC connector. Alright, and the two wires, wires go to the power outlet, which is connected to my Wavetek. I also reconnected temporarily the speaker to the radio in order to hear sounds, right? And initially I'm going to play the radio on FM, which in German is abbreviated by the letter U, which stands for ultra kurze Welle, okay, UKW. Okay, so U is FM. And that's exactly what I'm going to do, and hopefully we'll hear some sound coming from the speaker. If we don't, well, then we know we have a problem, right? Okay. So, yeah, here we go. Obviously, if there's some music playing, I'm going to extend the FM antenna somewhat. If there is some music playing in the background, I won't linger on the station, you know, because I don't want to get a copyright strike. I will diminish the volume, yeah, or switch the radio completely off, either way. So yeah, there you go. Volume. Okay, volume is on the on-off button. So I'm going to start at 39 volts AC. Okay. And we'll pump the volume up slowly until we either hear something or not at all. Or the thing goes boom, right? So like they say in English, here goes nothing. How can that be? I pressed the button for FM and I'm on AM. Let's see. What will... Oh, but I am on AM. Oh, I'm stupid. Okay. Okay, so here is the FM.
Er zijn 47 mensen gewond geraakt nadat een man met zijn auto is ingereden op een groep voetbalsupporters. Bijna 30 slachtoffers moesten voor verzorging naar het ziekenhuis. 2 mensen raakten zwaar gewond. 1 van hen is een kind. De voetbalsupporters waren in het centrum van de stad de landstitel van voetbalclub Liverpool aan het vieren toen het incident gebeurde. Op beelden is te zien hoe de man met zijn auto zigzaggend door de menigte rijdt. Hij kon snel opgepakt worden. Volgens de politie is er geen sprake van terrorisme.
A number of people have been injured and were taken to hospital. The car stopped at the scene and a 53-year-old white British man from the Liverpool area was arrested.
20 graden. Meer op 14nieuws.be.
Okay, that was the local news. The local news. Let's see. It's not very sensitive, I would say, on the FM band. When reception is good, the quality of the sound is good, at least on FM. And through my own stupid mistake, we started on the AM band, which was this button here. But okay, FM, I would say, works, but it's not very sensitive, and it's not very selective either. I don't know why, but my guess is whomever opened this module right here must have messed around with the settings of the tuner. Okay, so we tried out the radio on AC power, full AC power. It didn't blow up, which is a good thing. The power supply seems to work okay. The end stage, so the amplification stage, also seems to work just fine. AM, at first blush seems to work okay as well. FM, on the other hand, is pretty weak and not very selective. So I'm afraid that whomever opened the FM tuner section here, or I should say actually the tuning section right here, messed with it pretty bad. We will never know exactly why they did that, but I guess we've got our work cut out, right? Alright, the first thing we're going to do is to align the radio for the AM band and the long wave band. Okay, you'll need a few tools to do that, and in fact you will need a signal generator like the one I have over there, the Wavetek. Alright, but in fact any signal generator will do, at least for AM alignment, as long as it can go up to, let's say, roughly 2 megahertz. It should do. My Wavetek in fact goes up all the way to a bit more than 4 megahertz, and that's more than enough for at least AM alignment of a radio, at least for this radio. You will also need a VTVM, which means an analog voltmeter like the one I have over there. Now this is an old voltmeter, okay, so it's one that I restored a couple of years ago. It's an RCA. I'll put the link below the video of the restoration of the RCA, but in fact any analog multimeter will do, even a modern one, with one proviso: you need to find an analog meter which you can set to 0 in the center. Okay, for certain alignments that is quite important. So yeah, preferably an analog voltmeter which can be set to 0 in the center. Alright, and then you'll need a frequency meter, and I'm using my multimeter for that. Alright, now nowadays multimeters do have a frequency measurement setting as well. As you can see on my multimeter, there is a setting called Hertz, the HZ, and that allows you to measure frequencies. My multimeter can go up to, if I'm not mistaken, 10 megahertz or 11 megahertz, which is enough to do the necessary measurements. Okay, yeah, I hate this auto shut off, but yeah, I mean, nowadays it's quite hard to find a multimeter where you can switch off that auto switch off. Anyway, so basically what you need is a frequency meter, which in this case is also a digital multimeter, a signal generator, which can go up, let's say, minimally to 2 megahertz or higher if you can get them, and an analog voltmeter like this, or a modern version, provided you can set it to 0 in the center of the measurement dial. Okay, so yeah, if you have those 3 tools, you're all set to do the AM alignment, at least, of the radio. Now, I would also advise to buy yourself a few plastic or ceramic screwdrivers like this. This is a ceramic one, but I also have plastic ones like these. Okay, and the reason for that is that when you're going to touch ferrite cores, which we are going to touch, so ferrite cores are those black little cores you see in the center of these little transformers, you see, like the red one. Yeah, when you want to set a ferrite core, it's advisable to use either a plastic or a ceramic screwdriver and not a metallic one, because you have to avoid any sort of magnetic interference with those ferrite cores. Well, you can in fact use a metal screwdriver, but it'll make your life quite a lot harder, and not to mention that if you use a metal screwdriver, you might easily damage those ferrite cores. Okay, so there you go. Give me a moment to set it all up, and then I'll show you how to align the Saba Sandy for the AM and the long wave band. Remember, I told you that little vacuum tube socket which was installed in the center of the main PCB would be of importance later on, and indeed they placed that socket there to allow an easier alignment of the radio. Now, you need to remember this. The signals you can find, or the signals rather that you need for the alignment of the radio, are connected to the following pins of the socket you see on the main PCB. Alright, so you have X accent, X, D, M, then a couple of not connected pins, and then the ST pin. Alright, so for the AM alignment, you will need both multimeters, so the analog and the digital one, but each one for different reasons. And obviously you will need the signal generator. Now, the first thing you need to do is select the medium wave bands or the AM band. Once you've pushed that button, you need to connect your analog multimeter to the pins D and ST. So remember the layout of the pins. Alright, so you need to connect the negative of your analog multimeter to the ST pin, and the positive of your analog voltmeter to the D pin. Alright, and in fact I did just that with two little wires over there. Alright, so let me see if I can show you a little bit better. So there. Alright, that's how I connected it. I set my multimeter to the 1.5 volt scale. I think. Yes, I did. Yeah. So my analog multimeter is set to the 1.5 volt DC plus scale. Alright. I mean, certain multimeters, analog ones, have only one DC setting you can choose. This one apparently has two settings, so a DC minus and a DC plus volts. What you need to do next is to adjust the tuning capacitor to 1300 kilohertz. And then you need your signal generator, and your signal generator needs to generate a sine wave, an unmodulated sine wave of 460 kilohertz. And that's exactly what I did with my Wavetek. Alright, there. So that's about as good as it gets. Alright. It doesn't have to be super accurate, but obviously the closer you can get it to 460 kilohertz, the better. Alright, so the scene is set. Now we can move on to the next act. The signal I'm generating with my signal generator is injected by simple proximity, alright, to the ferrite bar, which is located under the dial right here. Okay, and that's more than enough. You don't need any physical contact, just proximity will do. I did connect up to the output of my signal generator the measurement probes of my digital multimeter to read off the frequency. Keep an eye on my analog voltmeter, and using a flat screwdriver, which is like this ceramic flat one I have here, okay, we need to set 3 spools, yeah, or 3 IF transformers, and you need to set them in the order I'm going to do it now. You will need to set this one over here, okay, so the 287/8, then the 213/4 right here. And yes, I know some of you will say this is not 213/14. This is not 213/4, excuse me. This is 213/14, but that's a typo. Okay, I looked all over the schematic. There is no 213/4 on a diagram. It's marked as 213/14. Okay, so the typo here is clear. Okay, so right here it says 213/4, and that should be a 14. And then you'll need to set the spool or the IF transformer 203-4, and the 203-4 is this one over here. Okay, so you need to set those three IF transformers in this order. When you keep an eye on the analog voltmeter, you will see the needle moving either left or right, and they say you need to do it for a maximum, which means you need to set the needle of the analog voltmeter as far to the maximum end of the dial scale, you know, as you can. 287-8. Okay, here we go. So I don't know if you guys can see this, but I am going to rotate the core of this transformer here, okay? And you need to keep an eye on the scale over there. So here we go, rotating it now. You see, now I'm going in the wrong direction. Okay. Oh, I went too far. Go back a little. There. That's about the maximum I can set with the 287-8. Now I need to set the 213-4. Okay. The 213, actually the 213-14. Okay. So let me show you. That one is this one over here. Okay. All right. Here we go. No. No. That one was pretty close. So there, that's the maximum. And then to end, I need to set the 203-4. And the 203-4 IF transformer is, well, is this one over here. Okay, in the corner right here. Okay. Here we go. Whoa. Whoa. All right. There you go. That's how you set the IF to exactly 460 kilohertz. Alright, so now the next step is to set the dial of the radio to precisely a frequency, a certain frequency. So you can move the dial of the radio all over a whole range of frequencies, right? And you want the pointer of your radio to always point to the exact frequency which is marked on the dial scale here, right? And for that you also need an alignment. Set the dial needle at 600 kilohertz. Now once you've set the needle to 600 kilohertz, you need to set your signal generator to 600 kilohertz. So it doesn't need to be super accurate, as long as you're, let's say, within half a kilohertz of the frequency that you need, it's okay. Yeah. So about there should do. Yeah, well, I'm a bit over. Let's say 700 hertz. So you need to be within, say, 500 hertz of the frequency that you need. Okay, which is not that simple, but there you go. There you go. Okay, so once that is done, the next step you need to do, you need to set a few capacitors and spools. Okay, so there is a capacitor here right under the ferrite bar of the radio, okay, which is designated on the schematic by the code L6-7. So the spool you need to set now is that one over there. But as you can tell, the needle of the dial, the frequency dial, is in the way. So you need to gently lift the needle, and then with your screwdriver, your ceramic or plastic screwdriver, you go into the ferrite core of the spool right here, and then you turn it for until you get a maximum on the analog voltmeter. It's not easy, but well, I'm past it. Okay, so there you go. I'm at the maximum. So the next thing you need to set is that thing over there, right there. Okay, and it's really not easy to get to it, but let's see. And while you're turning that capacitor, you need to look for a maximum. So let's see. No, wrong direction. Yeah. It's easy to overshoot, you know. 1500 kilohertz. You need to set your signal generator to 1500 kilohertz. Okay, so, and now you set the capacitor that I just turned, okay, so which is designated as C7 on the schematic, to get a maximum on the analog voltmeter. Alright, so capacitor C7 is the one over there. Okay, I think we're good. Yes, we're good. Now I need a break. I'm really tired and I need some food as well. Once I've eaten a bit and I've taken a half an hour break, then we'll move on to the FM alignment, which is quite a bit more complicated. If you're not interested, then I would advise you to skip at least the next 5 or 10 minutes. Well, the FM alignment is done, at least where I'm concerned. It took me quite a bit of time, I won't lie. It took me at least, I'd say, an hour and a half to get it right. And an FM alignment with basic equipment, I mean like a few multimeters like you see over there. So this one, that one, that one, and then a signal generator. I use a Nano VNA for that. So it's not a trivial thing, aligning a radio on the FM band. At least not with basic equipment, okay. It can be done, and I followed the instructions on the service manual, and it's quite a list. The funny thing is, they give the instructions in 3 different languages. So they give it, in English, in French, and in German. Okay. So yeah, basically, it all starts with the general settings that you need to do, and the general information, you know, like which measurement points you need to use, etc., etc. And then they explain how to align the IF, which I did, and then a whole thing, you know, all setting all sorts of windings, well, spools and capacitors and what have you, and then reading on the meters, yeah. And then the final step is the alignment, you could say, of the dial, okay. So if you tune into a radio station, you want the pointer of the tuning mechanism to point at the right frequency, right? So if you go to a radio station which is located at 100.5 megahertz, you don't want the pointer to sit on, say, 97 megahertz, right? So yeah, that's the final step of the FM alignment, okay. So that in fact, okay. I debated with myself quite a bit of time whether I should show you the FM alignment, but honestly it's not very exciting. It's tedious. You need to repeat a lot of things, so you have to go through the whole procedure at least a couple of times. Speaking for myself, I had to go at least I think 3 times. I'm not even sure anymore whether it was 3 or 4 times. Yeah. So yeah, it's not a trivial thing. So at least not with some basic equipment. And this also supposes that whomever wants to do an FM alignment has 3 multimeters, right? An analog one, like the RCA one there, okay, the volt ohmist, and then you need a multimeter, digital or analog, which is capable of measuring microamperes, right? As you can see right there on the dial, okay. So you need a multimeter which is capable of measuring microamperes, which I guess not everybody has readily. And also you need a normal multimeter, okay, so like this one. This is an auto scale voltmeter, well, multimeter, but it's really something everybody can acquire, okay, so it's not too expensive, a multimeter. That one was a little bit more expensive because it's supposed to be a bit more accurate, and it also has an analog readout next to the digital one, or I should say under the digital one, right? You see the analog scale there. So anyway, there you go. I did the FM alignment of the radio. You will need to connect a few wires to that connector over there. Alright. And for the FM alignment you will also need a 100 kilo ohm resistor, which needs to be in series with the M connector, okay, and the micro amp multimeter, so that one over there. Alright, so just for information, the negative of my analog voltmeter is connected to the X accent measurement point, so the most left one, yeah, the top left one. The positive of my analog voltmeter is connected to the X measurement point, okay, so the one right next to the X accent. Then the microamp meter, so the microcurrent meter, is connected between the measurement points ST dot and M, whereas the measurement wire with the 100K in series resistor there, okay, is connected to the M measurement point, so right there, that gray wire, yeah, and that goes to the positive of the microamp multimeter right there, okay. The negative of the microamp multimeter goes to the ST dot measurement point, so that point right there, the lower green wire. So there you go. If you follow these instructions and you follow the instructions on the service manual, you should be able to set the FM, yeah, to align the radio on the FM band. Well, I'm just giving you a friendly warning. Don't think that you'll be done in 10 minutes or so. You won't. Unless you're a seasoned technician who has done nothing but FM alignments on radios, a lifelong FM band alignments, you know, like somebody like a Shango or Bob Anderson or what have you, then, you know, those people will probably do it in 15 minutes or so, or 20 minutes tops. I'm not personally, I'm not an FM alignment expert, okay, so I just do it on occasion as an exercise, just to see how far I can push myself to achieve it or not, and there you go. Alright, so we need to mount back the little power connector of the radio into its designated spot, which is behind this opening here inside the radio, okay. And imagine that I even managed to find back both of the original screws which held the little connector. They were, as it were, floating around somewhere inside the radio, which, let's face it, is not very clever, especially since there is some AC going into it. So yeah, either way, give me a moment to mount it back and I'll show you the result once I'm done. Alright, I decided against using the original screws because when I tried to screw them in, I could hear the plastic starting to to break, you know, you can hear it crack. So I didn't go all the way, and instead I opted to use M2.5, so 2.5 millimeter brass screws, which are 10 millimeter long, okay, and I'm going to glue with a little bit of super glue the nuts for the screws to the back side of the AC connector, and that'll make my life a whole lot easier once I screw it back into its original place. And there you go. Don't they look cute? Right? Those brass screws. It looks way better than the original ones, actually. You know, the original one were just plain steel screws, you know. Nothing remarkable. At least these are brass. They will never rust, and they will oxidize probably, but really slowly. Alright, so there you go, and the connector is mounted back in place. Next we need to mount the speaker in its seat, which basically is right there. Okay, so these 4 holes here is where the speaker will sit. Now, before I mount back the speaker, I will draw your attention to the fuse holder that I mounted in this radio. Okay, so as usual, there was no fuse holder or fuse in this radio, at least on the AC side, so I decided to mount one myself. There you go. And I thankfully made use of an opening or openings that were molded into the plastic at the factory. So the gray wire goes all the way to the primary of the transformer, which sits there on the other side. Okay, so yeah, there's a 35 milliamps fuse in the fuse holder, which is actually a bit too much. A 20 milliamps would be more than sufficient. Let's scan quickly through the FM band, right?
Say the last just as the time bell rings. Gotta drive me crazy. I know you gonna want me, but when you want me, it might be a different story. I know. Keep your mind on the distance and the devil. Keeps believing I can't have it.
We scanned through the whole FM band. It's not a very sensitive radio. There are quite a few more FM radio stations where I live, but when those stations are a bit too weak, the radio won't pick them up that easily. But once it does pick up a radio station, the sound is, well, I wouldn't say perfect, but is quite good. Yeah. So for a little radio like this, it really goes really loud. I mean, the volume was only, let's say, a fifth open, yeah, and you could already hear it quite clearly, right? So once I open it up completely, it's really screaming loud. Although I have to say, at full volume, the quality of the sound rapidly diminishes. Okay. There's not much sense for me to run through the AM band, for the very simple reason that right now the atmosphere, is not conducive to helping AM radio stations coming in to my home. Yeah, the AM band anyway where I live is really poor. Yeah, there are just a few AM radio stations in the geographical neighborhood of my country, and most of them are weak. Strangely enough, though, I may not have said this before, one of the strongest AM radios to receive where I am, which is in Belgium, the strongest AM radios I can receive are either from Hungary or Spain or Ireland. Yeah, imagine that. So, but the local AM transmitters where I live are really laughably weak. I can barely receive them. So yeah, there you go. A final demonstration of the Saba Sandy portable radio. Now, there's one thing I wanted to show you. At the beginning of the video, I was struggling a little bit, telling you what type of batteries the Sandy runs on. Yeah, so you can slide this door to the right, and then you can just lift it out. So it needs 1, 2, 3, 4, 5 C-type batteries, or I think the designation is also R14. Okay, so R14 or C-type batteries, 1.5 volts, and you need 5 of them. All right. Yeah. So there is a little cubicle here, which I suspect was used to hide the AC power cable of the radio. Obviously, the original cable is lost, so I'm using one of my own. But I mean, that's not a big. That's no big deal. I can buy a new cable if I want to. Either way, that's what I wanted to show you to end this video. So there you go. So there, a fully restored, cleaned, repaired Saba Sandy portable radio from the 60s. In fact, the late 60s. Okay. And yeah, not the best radio I've ever had, but I'm sure for its price it must have performed quite well in the past, and it still does, of course, but it's not hi-fi, okay? So there you go. I hope you enjoyed watching me repair and restore this nice little portable radio, and I'll all see you back soon on my channel for another restoration. Thanks for watching.